Great. Well, thank you. First of all, delighted to be here and to be part of your event. I hope it's going well. Certainly to celebrate World Quantum Day, sort of World Quantum Week, I guess, now. Um, but I want to talk to you about secrets to working in quantum. So I've had multiple careers. I've been involved in quantum for about 5 years. And as I said, I'm in Washington, D.C. at the Quantum.Tech USA event. I moderated a day-long session um, on Wednesday on cybersecurity and quantum, and I've been moderating panels as well. I have a session this afternoon talking about quantum in metrology and sensing. So, more background on me. I host the Quantum Tech Pod, which is a series where I interview C-suite executives at leading quantum companies. This is just a screen grab. I did a really interesting session with Peter Chapman, who's the president and CEO of IonQ. You may know that's the first pure play quantum computing company to go public a couple of years ago. We had a great conversation. I just published my 70th episode last week. It was a conversation with Carmen Palacio Veraquero. She's based in Cambridge. She's the CEO of a company called New Quantum, focused on models for quantum networking. I also remember the Quantum Economic Development Consortium, the QEDC, and I host an initiative called Office Hours, where every month we have a 4 hour session in Zoom connecting quantum information science students with mentors in both the private sector and at national labs. So that we just did our April session last week. We're doing another one in May 23rd. I can send you information about that if you'd like to share it with students who might be interested in joining. Just confirming you can hear me and see my slides, okay?
Yes, yes, everything is fine. Please continue.
Okay, great. So I contend that humans have been using technology to solve problems for thousands of years, and certainly connected to physics. Back when the physics required the ability to throw a long stick with a sharp end at some animal to in order to eat and make clothing, when we were wandering around in the Pleistocene wilderness tens, if not hundreds of thousands of years ago, and implications for jobs and careers connected to technology continues. So here's a shot of a superconducting quantum computer. Today's jobs require technology as well. Quick recap on evolution of computers. I think it's good to set the tone and context for working in quantum. So you could go back to the Antikythera mechanism, the device that was discovered in the Aegean Sea in 1901 by some sponge divers. But let's begin with mechanical devices in the 1820s, which evolved into vacuum tube devices, and then into transistors and integrated circuits, and then today in the quantum era. Again, just background, Charles Babbage, an English philosopher and scientist and politician, invented something called the difference engine in 1822. It had 4,000 moving parts made out of steel and brass and could add and subtract. Actually, it was never built during his lifetime, but there's a version at the Science Museum in London. If any of you are traveling and in that part of the world, I encourage you to take a look at it. Pretty impressive piece of machinery. We then evolved to, comparatively modern computers. This is ENIAC, which stands for the Electronic Numerical Integrator and Computer. It took up an entire room. It was built in 1945 at the University of Pennsylvania and mostly designed to calculate ballistic trajectories, but it was sort of the first electronic calculator, computer, if you will. So used vacuum tubes, patch bays, quite a complex device, but at the time it was, revolutionary, innovative technology. It's evolved over the years, of course, into personal computers. This is IBM's personal computer from 1981. And now we wear this kind of technology on our wrist and exponentially more powerful. So pattern matching would indicate that quantum computers and quantum devices are going to have a similar trend and trajectory in terms of size and power. I want to share with you the fact that quantum is a constellation, if you will. It's not one thing. These are the four meta categories when thinking about private sector as well as government applications. So writ large, it's computers, it's sensors, it's networks, it's cryptography. I want to give you some backstory or definitions on each of these. So quantum computers, as I'm sure many of the participants know, is a new technology for computing. It leverages the law of quantum mechanics, the power of parallel processing, produces exponentially more powerful performance. It enables completely new computing capabilities. When talking about quantum computers, I always like to share what I call the sort of cocktail party aphorism that you can share with your friends when they ask you about what quantum computing is, and that's quantum supremacy. So in 2018, Google announced that with their 54 qubit Sycamore quantum computer using superconducting qubits, had solved a problem in 200 seconds that would have taken a classical computer 10,000 years to solve. Now, IBM immediately said, well, we could have done that in a weekend, 2.5 days on our Summit supercomputer. But the implications for any organization, which is every organization, is collecting and analyzing and rationalizing large amounts of data is tremendous, right? Quantum sensors are seeing lots of advancements in both medical and geophysical applications. It's a new generation using quantum systems that are much more sensitive than classical sensors, certainly able to detect subtle gravitational changes. We're seeing applications in GPS denied environments, like in submarines and in mines, um, looking for natural resources under the earth, and certainly medical applications for detailed imaging. There's a company in the UK called Circa Magnetics that's developed a 3D printable, wearable quantum sensing device to detect childhood epilepsy with implications for other, brain issues, looking at Alzheimer's, for example. So this is an area that's getting a lot of focus and demonstrating a lot of viability in the near term, right? Real world applications that are delivering business value. Quantum networks, so using photons to send and receive data. Lots of test beds going on in the UK, in the US, University of Chicago. As an instance, companies like Qubitech and QNect, which is based in New York, looking at ways to encode data in quantum states to deliver unhackable encrypted messages over long distances. More broadly, I think that exciting implications are for potentially distributed quantum computing, connecting quantum computers into networks. And worth noting that this is not going to replace, but rather augment the classical internet. Quantum cybersecurity, which is top of mind. I'm here in Washington, D.C. again at this event, and I led a day-long conversation around Y2Q, right? The day when quantum computer can crack present-day RSA and ECC encryption protocols. No one really knows when it's coming. Some predict 2030. The US government has said that all agencies have to have plans in place anticipating 2035 as the date when this might happen. Puts financial, military, and research data at risk. It addresses the threat of what's called harvest now, decrypt later, where competing companies and non-state actors and even countries and general hacker community members are stealing data and parking it, thinking that within 5 or 7 years they'll be able to decrypt the data and then maybe use it in a ransomware attack, or competing companies might be at risk. Countries that are adversarial might share data. So it's a real risk that's happening today that certainly companies need to address, and governments as well. NIST is the National Institute of Standards and Technology here in DC, and they're putting together recommendations. They've already done one tranche. They're due to release another set of quantum safe algorithms. They're saying, I queried a NIST person in my session actually, couldn't get a hard and fast date, but they're saying soon. So probably my guess is this summer. Two approaches, quantum key distribution and post-quantum cryptography, math and physics based. It's still conversations going on around, which is the best application. Are we going to use QKD for some secure communications and then post-quantum cryptography for others? It's an ongoing debate, but again, represents career and job opportunities. There are several companies, I'll show you some screen grabs, that are going to market with portfolios, with offerings that address this near-term threat today. Just a general quote around quantum implications for business and private sector, right? So this is Bob Suter. He's a former IBMer. He's worked at Inflection. He's now a analyst at a company called Futurum. His contention is many industries are currently working with quantum solutions, including banking, capital markets, insurance, automotive, aerospace, and energy. And his prediction is that in years to come, the breadth and depth of the industries leveraging quantum will continue to grow. And what that translates to for all of you interested in working in the space is jobs and careers across a range of verticals and certainly a range of disciplines. I'm going to share that perspective with you in a moment. The quantum effort is worldwide. Most major industrialized countries are focused on this and realize that there's value and also threats that need to be addressed based on advances in quantum technology. These are just some numbers from 2022. Countries like France spending 1.8 billion euros. The US is very focused on it. The UK has been very interested in promoting quantum technologies. We're definitely seeing funding at a national level, at a sovereign level, if you will. And many countries are putting together what they call national quantum strategies. Certainly the US has one, the National Quantum Initiative laid it out. The UK has one, France has one. More and more countries are realizing that this needs to be addressed at a national level. And the implication is there's money going into these various initiatives in different countries all over the world. Again, jobs, careers. What it generates is a whole new landscape of companies that are going to market with offerings that represent opportunities for people talented in quantum across a range of disciplines to get involved and do interesting work in this space, right? This is by no means quantitative, but it's qualitative, calling out enabling technologies, companies dealing with applications and consulting, certainly hardware manufacturers, and it's across a range of verticals as well. So chemicals, materials, and biotech is a big focus. Financial services is definitely very interested. There are a couple of companies, including Multiverse in Spain and Terra Quantum in Switzerland, that are focused on financial services applications of quantum computing specifically. So again, a range of opportunities, right? This is sort of the money slide I want to share with you. I call this the evolving quantum workforce ecosystem. So certainly there are scientists and researchers at the center of these quantum technologies, but there's a whole range of adjacent and ancillary skill sets that are needed. Keep in mind, these are businesses, these are companies that are looking to generate attributable revenue, right? They're not doing this for fun. So a business model requires lots of additional skill sets besides just scientists and researchers. Certainly executives, C-suite and founders to run the company, and business development in the upper right. So sales, whether you're a big company like IBM or a comparatively smaller company like Quanta, which is now Inflection, you need someone to go to the client who has a checkbook and convince them of the business value of this quantum solution. And that's an important role for sure, the tip of the arrow, if you will. UX design, people forget that quantum solutions require a human computer interface. So someone's got to figure out the best way, the most efficient, most intuitive way to physically interact with these devices, right? Education, the profession enables all other professions, as you all know. Many roles in teaching settings, right? Academic settings, both in person and online. MIT offers courseware, Coursera, online curriculum marketplace. Someone's got to be interested in having regulatory and policy conversations with government agencies. How are we going to manage this? Make sure that quantum solutions are developed and deployed and monitored in an ethical way. The bottom box, lasers, drill fridges, and test benches. I call this the sort of picks and shovels, if you will. Companies that are making devices that quantum companies are using to develop innovative solutions. Lower left, certainly comms and PRs, people that can write about this technology so that lay people and or investors can understand what it is. Marketing and branding, pitching to clients, potential clients, customers. And then investing. So all the major banks now have focus areas that are looking at quantum, right? Both for internal applications as well as clients. Clients want to know where we should invest. Where should you put the smart money? What's the return on investment? What's the time frame? Is it 5 years, 7 years, 10 years, 20 years? Which of these quantum solutions is going to generate attributable revenue and shareholder value? And then top left is strategy consulting. Some people contend that these are the companies really making money currently in the quantum workforce setting, going to clients and trying to talk about, long-term business value. So McKinsey, Accenture, EY, BCG all have desks, consulting desk practice areas that are looking at the value of quantum in the workforce. Just want to share sort of pictures with you of real world people doing work in quantum today. So to make it, real for you, these are actual colleagues that are doing interesting work across a range of disciplines. So this is not esoteric or phantasmagoric. This is a set of people in the space. So Maria Schuld, if you don't know her, she's a senior researcher at University of Durban in Natal in South Africa, but she also consults with Xanadu, which is a Canadian-based company. Sylvia is a marketing manager at IQM, which is a large Finnish quantum computing company. Jerry Chow is the director of quantum infrastructure at IBM. IBM, as you know, has a big quantum presence worldwide. Will Zhang was the head of the quantum research desk at Goldman Sachs and was poached last year to be a managing partner at Quantination, which is one of the seminal venture capital firms investing in quantum. Brian Mozendu is actually getting his PhD in Boulder, Colorado, UC Boulder, but he's the president of One Quantum Africa, representing efforts on that continent around quantum. And Dr. Basma Al-Buhairain is the managing director in Saudi Arabia for the Center for the Fourth Industrial Revolution. And she's doing real world work. I met her at the Dubai Conference, Quantum Innovation Summit in February. So again, a range of focuses, but real world applications of quantum that are generating revenue and representing jobs and careers. Right? I want to share with you some screen grabs of websites by quantum companies that will give you a sense of what the marketplace is, what the landscape looks like for careers in quantum, right? So this is Rigetti. They're a superconducting quantum computing company. They're based in Palo Alto. They were founded by Chad Rigetti, who's a former IBMer. They're looking for, quantum test engineer, as you might expect. But they're also posting something that they call future open positions. So the net of this is they're not sure what the portfolio will evolve into, but they want you as a smart person interested or talented or experienced in quantum to share your resume with them. So I encourage, again, anyone interested in getting involved in quantum that has the skill set to go to their website and click on this link and put in your resume. The implication is they may get a new executive hire, they may get a new client engagement, they may get a funding round, which will cause the portfolio to expand, and they want to have smart people who understand this domain that they can call on to join the company and help them drive the business model. I haven't seen that anywhere else. Again, I worked at IBM for 15 years, just for backstory. I never saw anything like this at IBM, for sure. But so the indication is, again, it's a fast moving, changing target and landscape, which again represents opportunities for people interested in working in the space. Talk about quantum computers and AI. This is a company called Zapata AI. They recently changed their model from just being focused on generating quantum software to connecting it with AI, and they now have their catchphrase is they're generating industrial generative AI solutions for the enterprise. So it's a fascinating company doing interesting work. They just went public through a SPAC with Andretti Motorsports, Mario Andretti's Formula One racing company. They're looking for a senior quantum engineer, right? But they're also looking for a part-time office manager. And many of these jobs can be done remotely. And the implication being you might not have a PhD in physics, but you're interested in this domain. You could get your proverbial foot in the door by being a part-time office manager and then navigating into the organization more broadly, taking on more strategic kinds of roles, moving up the value chain, right? Entry level to top of the function. They are also looking for interns, many of these companies, right? So here's just a powder research intern opportunity. Go to Cambridge, Mass, and work for a summer. And again, build your network, make connections, learn about the business as a way to stepping stone to further opportunities in the quantum space. This is that company that I mentioned before. This is a picture of their 3D printable wearable Meg scanner. They just got funding from a company in the UK, Quantum Exponential. They're a VC firm based in London. They're looking for a software engineer, a quality engineer. They're doing really interesting work, innovative work like today, looking for FDA approval and approval in the UK to take this to market, and also looking for how they can expand it to address other issues. I mentioned it's focused currently on childhood epilepsy, but there are lots of other applications where this kind of sensing capability could be leveraged in medical applications. So let's talk about quantum networks. There are several companies approaching this, and again, in the private sector, and doing partnerships with local network providers like Verizon in the US, for example, leveraging the existing fiber infrastructure. This is a company called QNect. They're based in the Brooklyn Navy Yard, just outside Manhattan. And they're looking for, again, a range of people with skills, an optomechanical engineer, optics laboratory assistant. They just announced a test bed that, hello, can you hear me? Still good?
Yes, yes, everything is fine. We hear you. Yes.
Pretty good. So again, these are real jobs. If you're interested in quantum networks, you should go to their website, look at their career page, and see what the opportunities might be. Quantum cybersecurity, again, a big focus area. There are many companies going to market. Sandbox AQ is probably a leading contender. They were spun out of uh, Google in March of last year. They're dealing with many government agencies in the US. This company is called Crypt, and they're looking for, embedded system software engineer, FPGA engineer, full stack engineer. This company was founded by a gentleman named Dennis Mandich, who was in the CIA in the US for 20 years and was so appalled at the rate and pace at which data was being stolen and hacked from the US government that he left the public sector setting and set up this company called Crypt and putting together solutions for doing audits around where cryptography is in your organization and how you identify mission critical data based on security protocols that he's leveraging from his role in the US government, and then putting together solutions for how to protect that data. So there are lots of ways to get involved. Again, keep in mind that quantum is a landscape. It covers the four main categories that I mentioned: computing, clocks and sensors, quantum networks with implications for memories and repeaters as well, and then post-quantum cryptography, quantum and cybersecurity. So I encourage you to explore and get involved. There's lots of opportunity, lots of ways to do interesting, creative jobs and careers. Again, we're on some level, we're making this up as we go, which makes it very exciting. Quantum is a very robust community that's growing, very collegial, I found in the 5 years I've been involved in it. People are realizing this is a net new technology, so it attracts creative, innovative people who want to help design and develop and deploy this technology to generate benefit for how we work and live. So quantum information is a constellation. Many opportunities exist, more are emerging. Get ready to work in different settings and different roles. You may join in a biz dev role and then discover you're interested in policy and regulatory conversations. Or you may take on a PR and comms role and discover that you're more interested in sort of investment guidance or business strategy conversations. Again, these are businesses organizations in public sector that are going to need people with skills in lots of different areas. I encourage you to keep learning and exploring. And I also encourage you to network, right? The adage that used to be described for getting success in showbiz is true now in every biz, and that is, it's not what you know, it's who you know. So I always encourage people to try to add 5 people a week to your LinkedIn profile. Put in some Boolean parameters at the end of the day and say, look up who's doing what where and find interesting people to connect with. Again, LinkedIn is the lingua franca. It's the coin of the realm. It's where the conversation around quantum is going on. And the more people you're aware of and companies that you follow, the increased success you'll have. Improves your odds. As Pasteur said, luck favors the prepared. So we're not sure what the quantum future will bring, but we're going to find out together. And I look forward to seeing you all in the quantum-enabled future. I encourage you to connect with me on LinkedIn or send me an email. Here's my email address, chris@improvisingcareers.com. And I'd be happy to continue the conversation with you. So let me stop sharing and see are we taking questions? Are people able?
Yes. So let me first ask to thank you for very nice and inspiring presentation. And also as a chairman, I will thank you for keeping well allotted time. So now we have a lot of time for discussion and questions. So who would like to to pose the first question? Who wants to start?
Don't be shy. None of this will be on the test.
Yes. Zoom. Okay. So please, could you read the first question, or is it, or you want to, sorry, you want to pose it, you can pose it directly. Yes, please.
Yeah, I think you can type it in the chat or just speak if you have a
Yes,
microphone.
just please unmute yourself and start talking.
Okay, thank you. I don't know if it is to me.
Yes, we can hear you, but
can hear
please
you.
try not to speak too
Yeah.
fast. Okay.
Okay. Okay. So my question is concerning African situation. For example, if Professor Bishop goes to the slide 17 that he showed, we noticed that they are founding for different continents around the world, but in Africa, we noticed nothing. So the question is, how can African work in quantum without funding, without founding? What's the advice that you can give us to us young African who really wants to work in quantum? So what can you advise, or where should we start
So it's a good,
in this situation that we have?
no, it's a good question. There are several people I can connect you with. I can share names. There's an organization called One Quantum Africa that Farai, a colleague of mine, is leading. There's also a woman in Zambia who's doing work in quantum. It's a small community, but it's growing. There are increasing number of people who are interested in discovering quantum in Africa. The woman I mentioned in the slide showing real world people, Maria Schuld, is someone else. She's part of a research team in South Africa that's doing really interesting work. She's a brilliant scientist. Again, someone you could connect with and query her, have a 30-minute informational interview in Zoom and build out the community. It certainly represents opportunity. It's not as robust, say, as Western Europe or certainly the US, but I would encourage you to connect with those people. I'd be happy to share those names. Connect with me on LinkedIn and let's continue the conversation.
Thank you. Thank you very
Okay,
much.
okay, thank you, Prof.
And in the same vein, you gave some advices to Africa. The situation here is very different, but do you have any special advices to Ukraine?
Here, hang on, my computer is fading. Let me plug in the power. For Ukraine, there's lots of quantum activity, certainly in Western Europe, right? There's a large community in the Netherlands, for example, focus in the UK. Again, because it's an international effort, I'd be happy to connect you with or point you to resources in that space. I would encourage you to set up capabilities around workforce conversations, right? I think it tends to skew towards science, which is not a bad thing, obviously. I mean, that's where this technology is coming from. but setting up some kind of community or consortium where you're talking about quantum and workforce. And then there are organizations similar to the QEDC in the US that are in place in Europe that you could apply to join and get involved in the conversation more broadly. So I'd encourage you to do that for sure.
Okay, thank you. And there was another concern. So our colleagues here mentioned that some time ago it was possible to use the IBM quantum computer from Ukraine domain. And now this is the case still, for instance, in Poland. I am from Poland. However, if you try to log in with the EU Ukrainian account, you are not allowed to. Are you aware of this fact?
I'm not aware of it, but I'd be happy to help you address it. Again, I
Okay.
worked at
And you know,
IBM.
can you guess what was the motivation? Very ridiculous. They claimed that they cannot distinguish between Ukrainian and addresses on the one and second side of the front. So basically, that the people from the occupied territories or possibly Russians could log in, and therefore they decided to close it at all, which is, from my perspective, a very stupid solution.
Well, I agree. I mean, I'd be happy to help investigate that. I know many people at IBM Quantum. It sounds like doesn't sound like a legitimate excuse, but there are also other settings where you could gain access to cloud-based quantum infrastructure, right? The first one that comes to mind is Amazon Bracket. Are you familiar with that setting? So Amazon Web Services hosts something called Bracket, and they provide public access for researchers and businesses to, I think they currently have 4 or 5 qubit modalities. Sort of a gateway to trapped ions. You know, they have lots of ways you can get involved and run, you know, projects or experiments or algorithms on their infrastructure.
Thank you. So one of the colleagues here from Ukraine would like to add a word to it.
Yes, please.
Yeah, hello. IBM put Ukraine into prohibited countries list. So I have my IBM ID quantum researcher since 2016. Now they blocked my ID and mentioned that I could renew from another country. So Ukraine now is in prohibited countries list because of US trade sanctions, which are actually not applying to Ukraine, it's applying to Russia.
So Ukraine is treated like Russia from this perspective, which is very, very strange for us. And do you have any chances to contact with some competent people at IBM to change this?
I do. There's a woman named Petra Florazone. I think she's in Germany. She's a colleague. She was in Dubai with me, and I'd be happy to introduce you to her, and you can have this conversation with her about getting access to their infrastructure.
Okay, thank you very
Thank
much.
you so
So
much.
maybe you can write an email to Christopher and continue on this.
Yes, send me a
So,
note, and I can
thank
reply
you.
and copy her, so we'll get her involved in the conversation.
Thank you very
so
much.
because we're living for a year only in simulations mode.
Yeah.
Yes. One more question from Christine.
Thank you, Christopher. Dear Christopher, thank you for this talk. Thank you for coming, for joining us. It was fascinating to hear you here at the Lviv Franko National University. So thank you so much for coming. Thank you.
Well, it's my pleasure. Thank you.
Yes.
for
So let
inviting
us thank the speaker once again. Thank you for visiting us from US. I think this is Christine. This is the visitor who did the largest path, in a sense only online, but still we have no other speakers from US today, no. Okay, so Christopher, once again, many thanks.